2016, question 10a. Now, the first part says, at time t seconds, the acceleration of a particle is given by a is equal to 8t plus 4. That's my starting equation. At t is equal to 0, the p passes through a fixed point with velocity of minus 24. And then it says, show that p changes its direction of motion only once in subsequent motion. So after a certain length of time, after t seconds, if p is going in that direction and it changes its direction, it starts to come back here. So this happens after a certain length of time t. When this happens, the velocity will be 0 because it'll stop and change direction. So those are my limits. Question says, show that this only happens once, so it doesn't change its direction more than once. I'm going to just use these variables dv and t. I'm going to make this dv dt is equal to 8t plus 4. I'm going to separate the variables. dv is equal to 8t plus 4 dt. I shall put in my integral signs and I'll put in the limits. So the limits are going from 0 to t for the time and from minus 24 to 0 for the velocity. Right, so off I go, I integrate it. So this becomes v is equal to 8t squared over 2, which will be 4t squared, plus 4t. Okay, limits going in as we said, t 0 to t, this one minus 24 to 0. So this becomes minus 24 is equal to, when I put in 0 for all this, it's just 0 minus, now I put in the t and get 4t squared plus 4t, and then look what I have, a quadratic is equal to minus 4t squared minus 4t. Bring everything to one side, divide all the way across by 4, and this will give me t squared plus t minus 6 is equal to 0. Solve for t and I get two values, 3 and 2. That'll be plus, that'll be minus. T is equal to minus 3, t is equal to 2. Of course I can't have a negative time, so I ignore this one and I just take t is equal to 2. So since only one solution for t, changes direction only once. Changes direction once only. Okay. So, the second part of the question says, find the distance travelled by p between time is equal to 0 and time is equal to 3. Right, the distance travelled. Now, this is my starting equation. A is equal to 8t plus 4. And if I want to get distance, I'm going to have to use v dv ds, because that's the only one that's going to link me acceleration to a distance expression. But if I do this, look, I have three variables, vs and t, so I can't use that. So in this case, remember, you go back to something you already have from the first part. Now we do have an expression for velocity. Look at this velocity up here. So velocity, remember, will give me a straight link into distance. So velocity is equal to 4t squared plus 4t. But then I put in specific limits. If I hadn't put in specific limits, I would have put in a constant of integration. So that's what I'm going to do. And that's going to be then my general equation. It should be 4t squared. Right, so I'm going to find t using my initial conditions. So the initial conditions were that t was 0 and v is minus 24. So t is 0 when v is minus 24. So this becomes minus 24 is equal to 0 plus c. c is equal to minus 24. So my starting equation now is v is equal to 4t squared plus 4t minus 24. Right, this will give me a direct link into distance. So this will become ds dt is equal to 4t squared plus 4t minus 24. So I'm going to use this equation now for the part 2 of the question. So part 2, I'm going to separate the variables. ds is equal to 4t squared plus 4t minus 24 ds. dt, not ds, dt, and integrate both sides. Now, the question asks me to find the distance between p, that p has travelled between t is equal to 0 and 3. So between t is equal to 0 and 3, something happens, because remember it changes direction after 2 seconds. So what I'm going to do is I'm going to find, first of all, the distance travelled between t is equal to 0 and t is equal to 2. And then I'm going to find the distance travelled between t is equal to 2 and t is equal to 3. So, and that will tell me the distance travelled then between, in total, because there is a change of direction. Okay, so I'll integrate this side. So s is equal to, this gives me 4 over 3t cubed plus 4 over 2t squared minus 24t. So this will be s equals 4 over 3t cubed plus 2t squared minus 24t. So my first set of conditions, remember, is going to be what distance is travelled. So what distance is travelled between 2 and 3, between 2 and 0 seconds. So I'm going to put that in. S equals 4 over 3t cubed by 2, which is 4 over 3 by 2 to the 4 to the 8, plus twice by 2 to the 4 minus 24 by 2. Okay. And when I work that out, I'm going to get minus 88 over 3, which is minus 29.33 metres. Okay, so that's how far it travels in the first part of its journey. Then it changes direction. So now I'm going to see what happens between 2 and 3. Okay, so I'm going to say S again equals 4 over 3t cubed plus 2t squared minus 24t. And this time I'm going to do it between 2 and 3 seconds. Sorry, 2. So I'm going to put in 3 seconds into this, s equals 3. I know what the 2 seconds is already. I'm after finding that to be minus 29.33. So when I put in 3 seconds here, this will become, so my distance will be equal to the distance travelled in 2 seconds, which minus 29.33, minus then the distance travelled in 3 seconds. So this is going to be 4 over 3 by 3 cubed plus twice 3 squared minus 24 times 3. And when I do all of that, when I work that out, I'm going to get minus, that becomes 18. Minus 18, actually. So when I add minus 29.33 to minus 18, I get minus 11.33. So my distance travelled between t is equal to 0 and t is equal to 3 is minus 29.33 in the first 2 seconds, and then another minus 11.33, which will give me 40.66. Now, this minus, of course, is a distance. It has to be a modulus, so it's going to be 40.66. 40.66 metres.